Now let's come to a hands-on part. In the beginning, we have shown you what we want to do. We want to create fair data. And then in the second step, was more about what methods we are used to do this, that we're using this NeXus standard. And now let's show you some examples. So I'll show you the two possibilities, pynxtools and the H5Py package to generate the fair optical data. And just in the beginning, I also already provided it once in the chat, but I'll again share this the material with you. You can find on this, I posted in the chat, let me show it here, the event webpage. And on this webpage, you can find here in the bottom the material which you can download. Yeah, please do this. Download this material right now. We will use this. Yeah, you can download it and then you have to extract it, like here. And then you should have a folder with these files here in. Yeah. In this folder, you have a text file with links. It looks like this. And here are various links in it, which you can also use here. I again see here a typo, which I also had the last time. Okay. So let's continue. So this is the material. Okay, I hope that everybody is downloading this right now. And then let's come to a small short overview what I want to present you today. So the starting point is that we have raw data or an electronic lab notebook entry. And in the end, we want to convert this data to a NeXus file. Yeah? And I show you how to use the tools pynxtools to do this for Raman and ellipsometry data. And I also show you the H5Py package, how to do this. But of course, there are also many other techniques how you could achieve this. Yeah, but today we focus on these two methods. And now let's first in the beginning, let's start with the NeXus file. What is a NeXus file? Shanda already gave you an introduction where all this NeXus definitions and standard comes from, what it covers, how it is structured, what the possibilities are with that, and the potential. In general, in short, I just have here for you a quick equation. A NeXus file is sort of just an HDF5 file. Yeah, this is a container file format. And then, in addition, you need to have the NeXus definitions. The NeXus definitions, so to say, give a specific structure which you have to use for this HDF5 file. And the content of the HDF5 file can roughly be separated in groups, fields, and attributes. This is all you need to make a NeXus file. You need your HDF5 file, groups, fields, and attributes, and then you have to provide this with a structure. Let's come to the NeXus definitions. Yeah, okay. Here again, shortly an overview of a NeXus file, of an HDF5 file. An HDF5 file can contain groups. Yeah, groups can contain data sets. Groups can also contain groups. And in principle, everything can have an attribute which describes this group or data set in more detail. All right, let's come to the NeXus definitions. Let's go to this web page. I'll copy paste it into the chat. You can follow it if you want. And here on this website, you have here are all our projects from the Fermat, from the experimental section of the Fermat project. You can see here also other different experimental techniques, and we are covering today optical spectroscopy here in this. And here, what you can find here is a short overview of all the parts of optical spectroscopy, what we have right now. And if you click here on this link, the this NX optical spectroscopy, you can come to the NeXus definition of optical spectroscopy. Let's have a look. And this is how the human readable version of the NeXus definition looks like. Yeah, this is the HTML version, what Chandra mentioned. This is what we are gonna work with. I also copied a link and post it into the chat, so you can also have a look. You can go through this and see various different elements. Yeah, for example, you see here an element which describes the start time of the measurement of the experiment. You have something to specify the experiment type. Yeah, for example, in photoluminescence measurement or transmission spectroscopy measurement. You have experimental identifiers. And then you have also a part where you can describe the instrument itself, what you use for the measurement, yeah. Different angles for reference frames, and also important parts are, for example, something to describe the beam properties, the detector, and also a light source, yeah. You have also a little bit lower somewhere a position to describe sample properties and so on. And this NeXus definition here, this gives you the structure. This is what you have to use as structure to sort these groups, fields, and attributes. And if you follow this, then you can create a NeXus file. There's not only optical spectroscopy, but we have also optical spectroscopy can be used to specialize some specific techniques, for example, ellipsometry and, for example, Raman spectroscopy. This is NX Raman and NX ellipsometry here. But you can also use the generic optical spectroscopy definition, yeah? For the Raman, the thing for the specialization of Raman spectroscopy, for example, is that you have at the instruments level, you have something to describe the scattering configuration. Yeah, this is something what is present in the Raman NeXus definition, but not in the generic optical spectroscopy definition, because this is only a parameter of interest for Raman spectroscopy. The same way, ellipsometry is a specialization of optical spectroscopy and has some elements, for example, here rotating element type, which are only necessary or required for this ellipsometry definition. And so we have these three types: the generic optical spectroscopy definition, ellipsometry, and Raman spectroscopy. And this is also, you can also find these things on the website. If you follow here the link on the left side to optical spectroscopy, then you see here ellipsometry, and you can see here the application definition. You can click on ellipsometry, and here you have the specialization, the additional elements of optical spectroscopy which are required for ellipsometry. You can see here it is extends optical spectroscopy, and the same holds true for Raman spectroscopy. Also here an extension, and here are different other elements, and for example here is a scattering configuration. All right. Yeah, then this is how some of these example NeXus files can look like. I also provided you these files. You can find them here in the download material. And I would like you to use these files to open them in the browser. There are two different possibilities to inspect these files. I'll again post these links into the chat. In these websites, you can open the NeXus files, and then you can inspect them. Yeah, for example, here I have here my files, and here is the Raman file. I think I can just drag and drop it. Yeah, and then the file is opened in the browser here, and then you can inspect this NeXus file. Yeah, I would like to you do this and take a look what you can find in there. just to get a little bit impression, click a little bit through these elements. For example, here the instrument level, you can find several information about, for example, the laser. You can see here that this laser, the associated source, this is something what is required for a beam path description. And then you can also see, for example, the average power. You only read here 60, yeah, but here in the top, you also have only not the display button, but the inspect button. And then you can see here the units. The units are actually an attribute. You can see the incident wavelength. Also here again, nanometers. And then you can go through this a little bit. All right. I hope that you can open these files. If someone has a problem also, if we can help somehow, please let us know. Would be cool that you can take at least a short look into the file, click a little bit through this. And in principle, this file is a representation how this such a fair data file can look like. Yeah, the idea is that you later get the sense this such type of file from a colleague, and in this file everything is contained what you need to know to understand the experiment. There you will see the beam path, you will see all measurements, the integration times, and so on. And this should be enough to understand what this experiment was about and how this was done in detail and so on. Yeah. For example, here just I just sum up what you shortly can find there. Yeah, you can find also the measurement data itself in this file. For example, here you can find here the spectral data. Here, this is the spectrum. This is the wavelength spectrum from starting from 530 nanometer up to 660. Then you can convert this to a Raman shift. And if you click here on the data, then you will see on the bottom here the Raman shift and the intensity. These data here are only, so to say, the matrix, the arrays, so to say. You can also take a look here. Yeah, you only have this list of elements with wavelength. Here you can see the Raman shift, and here you can see the intensity and counts. Yeah, this is how such a NeXus file looks like. This is where we want to go. You can find the metadata, information about the laser detector, lenses, and also sample properties and so on. Yeah, all right. Yeah, so now let's, we've discussed a little bit what a NeXus file is, where we want to go. Now let's take a look how we can use pynxtools to get to such a file. And for this, we use pynxtools. And this is also a part where you can do it with me together, and hopefully you can also convert a file. We will use these code lines here to first create a clean Python environment, where in principle only a clean Python installation is present. We don't have any packages. Then we install here the pynxtools. Yeah, there are several other packages which are required for pynxtools. Then we can also install the pynxtools with the ellipsometry plugin. Then we can use two files which I also provided you in the download here: the ELN data YAML file and the test data file. And if you have then if we have then this pynxtools with the ellipsometry plugin, we can use this command here to convert the files into a fully functional NeXus file. So let's do this. For this, I switch to my Linux computer, and right now I have to download the file. Yeah, this should be this here. I have to organize myself here. So here we have the event. I download the data here. And I copy this file to my drive. No. Here. And extract it. All right. So yeah, I have Visual Studio Code to access these files to work with them. And first, let's have a look what Python packages we have installed. Yeah, you can do this with piplist, and you can see quite some packages inside. But I don't want to start with a already set up Python environment, so I'll create a new one with this command. I'll also paste it soon to the chat. So what I have done now, I have created a new Python environment with this line, and then I have activated it. Yeah. Now if we do a pip list, you can see all the Python packages which are installed, and this is only pip and setup tools. So only supportive Python packages. So for example, we don't have any NumPy or anything like that. Let me copy the Python commands into the chat. I hope this works for you. And then I will install pynxtools. Yeah, so what you see here in the list, we don't have pynxtools installed. Yeah, nothing is here. But now we will install pynxtools with the command pip install pynxtools. So this will process a little bit. Takes a little bit time because it's downloading various other packages which were required for the functionality. I paste this into the chat, this command. And what we now can check is, again, with pip list, see what was installed, yeah? And you see here various packages, for example, pandas, and h5py was also installed. But what is also installed is pynxtools. This is the main package here, what we are using. And this we will use. But we want to use the example for the ellipsometry. Yeah. So we also have to install the plugin, the ellipsometry plugin. And this is done by these brackets behind the pynxtools. Yeah. I've added here the brackets, ellipse, and then the bracket closed. And if you do this, it installs also the pynxtools ellipsometry plugin. We can again take a look, pip list. And now you see pynxtools. Okay, this was already installed, but now we also have pynxtools ellipse installed. And now we have the possibility to perform this data conversion. I will now take a look to copy these two files, and then I'll take a look into the chat. So let's see what files we have here. Here we have this test data dat file, the eln data YAML file, And then as we have installed the pynxtools, we can use the function data converter. Then we tell the package, the pynxtools, what to do. We want to use the convert function. And then, yeah, sorry, I have to reconnect shortly. And then we have to tell the pynxtools what reader we use. Yeah, whether we convert now a Raman file or an ellipsometry file. So we tell reader ellipse, the ellipsometry reader we want to use, because we also have installed this. And then we have to tell the program which NeXus definition language, NXDL, which we want to use. We want to convert an NX ellipsometry file. Ellipsometry. And then the last input what we have to provide is the ELN data YAML file. Let us short take a look how this file does look like. For example, here, this is the ELN data YAML file. This is, for example, an output, what you could have from an electronic lab notebook, yeah? It is structured in a way that already mimics the NeXus structure. You have here an instrument, then you have a beam, a source beam, then you have detector, you have different instruments here. You have some metadata, what spectrum type units, which software was used, and so on. Which ellipsometer type, then also some information about the sample, some information about the user. There are also some other information which are required for the conversion of the data for this specific setup. We have here an RC2 ellipsometer. So this specifies which data columns we have available and so on. And then an important thing is in this file here, you see here a file name for additional measurement data. Yeah. So here is the actual measurement data, the output from the setup. This is exactly here also located. This is the other file which you have had in the download section, and the principle you can with as the name of the other file is contained in the YAML file, we only need this as input. So yeah, and if you have now this input, then you can execute it. You see here using the ellipse reader to convert the given files. This is the input file, as it is only one file, and then it tells you that it has generated a file, and this file is output NXS is called. And this is exactly this this NeXus file. I hope that I would like to see that you can perform this this data conversion, and also that you can have somehow this pynxtools installed, because we need this later, and also the output file we need this later. So would be cool if some people or could give a little bit feedback if they need a little bit more time, or if I shall go through it again, so that you can do with me together this data conversion and in the end see this ellipsometry NeXus file. Okay, so now I've shown you how to use this pynxtools to convert this file. And here again, just short, this ELN data file mostly contained the meta information. Yeah, again, this is the file what you have to provide somehow. You have to structure it somehow, because mostly your electronic lab notebook will look differently. And then the NeXus file, this is mostly here the meta information. And then there's the test data file, which contains mostly the measurement data, which is usually the type of file which is otherwise shared on normal basis in laboratories. Just give me this text file and then I'm fine. But now we want to also have this metadata. Yeah? That's why we are doing that. This reader works specifically for the RC2 ellipsometer. Yeah, and just also here, we use here right now the pynxtools ellipse plugin. This is here the command which we use for the data conversion. The output is this NeXus file. You can also do this for the Raman stuff, for the Raman data. The command would look like this. You again have to install then the pynxtools Raman data, yeah, with this command instead of the ellipse. You put in here Raman. And then this should also convert this data here, and you should have this output. And yeah, just as final note, the most important thing is here this ELN data YAML file. This is the file what you have to provide to point to the measurement data you want to put in, and you also and it also contains the metadata, yeah, which sample, which user, and so on. This is what you have to provide to make this the pynxtools Raman or pynxtools in general work. Yeah. There was a question in the chat. The output file name was in the YAML file. The output file name. This is a default here. I think one can also change this. I think you can add here somehow an additional field, then you can rename it. I'm not quite sure about this. The output file name, you could change it to whatever you like. This is the structure of the ELN data. There was a question in the chat. The structure of the ELN data YAML file must follow the application definition of the of NX ellipsometry, right? In principle, it makes it easier, but in the end, the most important thing is encoded in the reader, which is specific for this setup, so to say. You could also structure it a little bit different, but this structure already makes it easier to convert this data. You can deviate from that, but if it already follows the structure, this is easier to pass in the end. You have some, yeah, to provide some pointers, yeah. This is the data where you have saved this, and then you have to tell it to which NeXus concept this refers to. All right. Yeah, so now I have shown you how the pynxtools and how the plugins work. And now I can come to a part where I show you how you can use H5Py to make this. This is a Python package. And the advantage is that you have you can integrate it in your setup as you want to do it. There's also disadvantage that you not have this easy the one-click possibility. Yeah, you execute just one command and everything is converted. But here in this point, you can include it in the setup as you like and you want to. And I also want to show you this. It is also a good way to get into this NeXus structure, to play a little bit around with it and so on. So what is H5Py? This is a Python package. It's a Pythonic interface to the HDF5 binary data format. You can see here again the structure, what an HDF5 file is. HDF5 file contains groups. Yeah, groups can contain groups, and groups can also contain data sets. And in principle, you can give everything attributes. And these are the three fundamental blocks which you have to, which are in the HDF5 file. And then, as I've said in the beginning, what is a NeXus file? It's an, so to say, this elements of groups, attributes, and data sets. And then in addition, if you have the structure, if you're following the NeXus structure, then you have a NeXus file. Okay, so let us see how we can follow this NeXus structure. Again, here you can go to the website of the Fermat project, where we have this NX optical spectroscopy definition, and here in the bottom you find this structure, and always such an NeXus file starts with an entry And in this entry here, there are defined specific elements which you may have provided in it. You have to give a definition, for example. You see here a field. It states that it is required. You can hear some other information about the data type and so on. And the structure is that in this entry, you have the definition. Yeah, on the same level, you also have title, start time, end time, experiment description, experiment type, experiment subtype, type other, experiment identifier. And then, for example, we can also take a look what is in experimental identifier. And then you can take a look here. Specifically in this experiment identifier, we have here a service, an identifier and identifier type, and then also is persistent. Yeah, these are all data fields here. These are, so to say, data sets. And this data set here contains if it is true or false. If this identifier is persistent, then you can have an identifier type. For example, a global or local identifier. You can specify here the identifier. Maybe it's a DOE or yeah. And if you follow this structure, this hierarchical structure, then you can create this NeXus file. All right, this NeXus definition is where you find the structure. And let me again repeat the basic elements because it is really important. You also have to learn how to read this the structure. Yeah, there's a website, and then you have this indentation, and then you have some different elements which highlights somehow different. You see here an @ symbol, okay. Then you see here an uppercase name, one indentation level lower. You see this definition, and then you have also the case here. Here, this is actually a NeXus base class. Yeah, you see here the experiment identifier is actually a NeXus base class. It's an NX identifier, whereby the other things here are just data sets. So this would be a group, and this would be a data set, for example. And it is really important to understand what is a group, what is a data set, and what is an attribute. Okay, let's go through. You see here a NeXus file. Yeah, just an example, some elements appended. Groups can contain groups. Yeah, for example, we have seen here in this, you can see here a group. A group can be inside a group, but a group can also contain data sets, okay? So you see here all these things with these arrows, so to say, are on the group level. We have the group entry, we have the group data, and we have the group instrument. And in the group instrument, there's another group. There is the group beam 532 nanometer laser, beam incident, detector, and device information, and so on. You have some fields. These fields are highlighted by this datasheet stack symbol, or what is this? You have here the spectrum data X Raman, spectrum data Y, definition, experiment description, experiment type. And then the last thing is the attribute. I have selected here the instrument level. Yeah, this is why you can see then there on the left side under attributes the NeXus instrument class. Let me. I have this here, for example, here. If you have here a NeXus file, you can go here to the instrument. You don't see here actually right now anything, but what you can do here is you can inspect it in the top right, and then you see here that it is a group, and it has an attribute, and the attribute is that this is a NeXus class, and the attribute is NX instrument. So this is how you know which NeXus base class this is. And you can also go here. You see here, for example, you again see this stack symbol. It's a data set. And And also this data set can have attributes. This data set has the attributes degree, and the attribute is called unit. These are angles of incidence. Let's take a look like this. It's a little bit better. You see here 50, 60, and 70. Yeah, these are the degrees of angle of incidence. All right. So now we have this so far. How do we create this now with H5Py? In principle, you see all commands what you need here on this page. That's everything what you need. In the beginning, you have to create. Of course, you have to install the H5Py package. I think it's pip install H5Py. Let me short look it up. Yeah, pip install H5Py. And then you can import it, this package. Yeah, then you have all the functionality in Python. And then you create a data file with the H5Py with this command. This is the name of the file, and then you specify here that you are in a writing mode. And then you can operate with this object. Yeah, it's now in. If you only perform these lines, you have just created this file, which is empty and does not contain anything useful. Just an empty H5Py file, which has the extension NeXus, NeXus file, and then you can add the content. Yeah, if you want to add a group, you use this line of code, create group, and then you have to specify the name. And we always begin with the entry. Then you can add a field. To add the field in the entry group, you of course already have to create it. Be created this this entry group. Yeah, but if you've done this before, then you can also add a field. This is the path where you want to add this field, and this is the name of the field, and this is the value of the field. Yeah, and this already here follows exactly the NeXus the NeXus definition. Let me go to NX Raman. We start here with the entry, yeah, and then we'll want to add the first element what we see, and we see here okay definition. Yeah, that's what we end. Entry and then definition. Okay. And then what we also have to do, always if we create a group, we have to assign this group a NeXus class, base class. And this is what is done with the last element, with the last command here. You oh, here is an F missing. Oh, sorry. Here there should also be the F. Oh, copy paste mistake. Sorry. With this command, you can then add the attribute. It's called NX class. This describes that we want to describe the NeXus class in more detail. You could also put in here units. Yeah, if you write in here units or unit, you specify the unit. But we here now want to describe that this entry is a NeXus entry base class. We have to do it like this. And in the NeXus documentation, you see this in the point where you add the entry. You also see here in the end this NX entry. Yeah. So this is, you have to learn how to use this web page to, because you have to transform this human readable definition into programming code. I also show this a little bit more in detail. Again, just the same example, so to say. Here we import the H5Py package. We create a file, which is called NeXus file creating workshop. NX example. This is in the folder, and this is the name of the file. In writing mode, we create a group called entry. In this case here, we create also the field definition, and we assign the definition value. The definition is a data set. Yeah, the data set can contain value. It can be a string. In this case, it is a string, NX ellipsometry, but it could also be a number. Yeah, 5, for example, or a matrice or something different. And then here in the last line, we assign this entry that it has an attribute, and that the attribute is the NX class, and the value is NX entry. Let us also take a look. We have here entry. Let us inspect it. We see here the entry is a group. Yeah, that's the path where it is. And you see here the NX class, NX entry. This is how it should be done. All right. Yeah, okay. Yeah, create the HDF5 file. So this is later for you if you have this file. How to create this file. This is, you create this box, so to say, here. With the second line, you create this field with this value. And then you can also add the attribute under the inspect mode. Okay, yeah, this in principle the 3 commands which you use, and then you have to go through this NeXus definition to fill out your file with the requirements which are stated in the NeXus definition. Yeah, so you go to the NeXus definitions website, scroll through, you identify groups, fields, and attributes. Yeah, I'll show you soon how this is done. You see here the attributes, for example, the attributes always have an @ symbol in front of. Yeah, so attributes are easy to identify. But entry and definition, they can also have upper and lowercase notation. This is not how you identify these. Let us take a more detailed look. I'll tell you soon how to do this. For example, here, let us again start with the attribute. Yeah, the blue thing here, that's the attribute, had an @ symbol in front of. You see here the notation, so to say, is @ and here ABC, some letters, a name. Yeah, this is the command which you use. So here again, the F is missing. I have to correct this. And then the notation for a NeXus group and the NeXus field. You can identify it by these fields here, yeah? By, so to say, this specifies here for the data set which type of data or which data types this should be. NX it should be a character, so to say a string or so, but not a number. And here NX entry, as here is no underscore, this indicates that this is a NeXus class, a base class. This is how you can identify them. There are also sometimes upper and lowercase notation mixed, as you see here. Version lowercase notation and URL is uppercase notation. Both are attributes. This can be mixed. Also, you see here detector underscore and then uppercase type. Yeah, this is, so to say, here the group. And you see it here, it is a base class NX detector. And for example, a way to implement the detector channel type would be that you have to you go to the entry, you say that the path starts with in the location entry, then you have this instrument, yeah. Then you have this detector level, and here's detector underscore type, yeah, and this uppercase letters can be replaced by anything you want, and you can have multiple of them. You can detector 1, detector 2, detector 3. You can also have detector diode and detector CCD and so on. So this is specialization, so to say, because setups can have multiple detectors, and there are various other elements where you can have multiple of them. And just specifically for this detector, then you have this channel type. This is the path for this, and then you have to select single channel or multi-channel. you specify this, and then you can add this specific element. Yeah, then you have to work through this NeXus definition. Again, just notation, this detector uppercase type is replaced by detector lowercase diet. It's a special case, so to say. You can also have diet 2. And this is in principle how you read or understand this NeXus definitions. Yeah, so then you can go all through all these elements. You see here, okay, experiment type. Then you see in the okay, you have here the underscore, and then you know, okay, this is a data field. And you see, okay, this data field has to be a character. And then you can read, what do you have to specify here? Specify the type of optical experiment. Okay, and then you see here, and okay, and then you see as obligatory varied Raman spectroscopy. This is reasoned by the fact that we are here right now in the NX Raman application definition. And for this, the experiment type is limited to Raman spectroscopy. Yeah. And in this way, you have to go through all the other elements, and you can add then the things you know, metadata and measurement data to the file. You have an example with you. This is a tutorial H5Pi example pi. Let us shortly take a look there. This is this file. I have put in here also some comments and so on, so that you can understand this. Here in this case, I have put it's not the instrument, but the instrument is called experimental setup, exp setup, and the detector here is called detector underscore CCD. And then here I specify the detector channel type. Yeah, this is an example, and then you can use this to extend your file, your script to convert your data which you have. All right. And we have also made a how-to for this procedure to see this in more detail. Yeah. You have also this link in your text file with links. I posted again this link just into the chat if you want to follow it or save it. So this tells you how to use Python to create NeXus files, and it really starts with the beginning. How do I install H5Pi with a simple example, and then the steps that you want to add NeXus concepts. So this data fields, attributes, and groups. Yeah. Show you how to add an attribute. I show you how to add a data field and so on. You can use this to hopefully create your this shows you the basics to create such a NeXus file, and then you can expand it, and then you ideally can implement this into your setup if you don't want to use this pynxtools capabilities, or if you just want to test some things and so on. All right, yeah, and also in this how-to, I've also shown you somewhere that there is, if you, for example, have here the NeXus definition of Raman spectroscopy, you have here a field where it states it is required. An entry is always required, and also you have to always define the definition what you use and so on. But there are also some fields which are recommended. Yeah, for example, a title of the file, and some fields are also optional. For example, especially in optical spectroscopy. The optical spectroscopy definition here, we are here now. You see some things which are here again recommended, but there are also some things which are optional. Experiment subtype, or a description of the reference frames and so on. What this is detailed more in this how-to. Also a little bit about this upper and lower case notation again, if this was a little bit too confusing. and also the specific examples, and also what is always important, that you have to include the NeXus version. Yeah, that you say, for example, if you use the 2024 version and you don't change your setup in 6 years or so, you still use this version, that you have to specify that you use this version. Otherwise, yeah, possibly some fields are missing or are not compliant with the NeXus standard. If a group or attribute is already available, will it be overwritten if I use it again? Was the question in the chat. I think it's with this package, it will just throw out an error message that this field already exists, and will cancel the process. If I'm right, if I remember correctly. So now I have shown you something about the pynxtools and also how to use this h5py package. How you can create NeXus files. You also have in the provided materials some examples how to run a Python example how to create such a NeXus file and so on. You can take a look into that later. And now an important part is, especially if you're doing this by hard coding, so to say, with h5py, as you see this here. This is just you have to manually put in the file names. You can also do it a little bit more advanced, but here, for example, in this example, I just typed in everything hard-coded. For example, if you have now a typo in there, detector with double T or something like that, you maybe as human would see that this still most probably references to detector, but the ELN database, which uses the NeXus files input, will not know that this is the detector. And maybe there are some things which are required. For example, if you do a Raman measurement, I would like to give you the wavelength of the incident laser. At least, if you don't provide it, I can't use that data. So there are some things which are required. Or necessary in a specific structure to have a valid NeXus file. And this, before we can push this data into a repository to have fair data, we want to verify this data. Yeah, we want to have a software which takes a look again at the things and at least tells us, yeah, okay, all these elements which you added are fine. For example, the field, the NeXus definition requires you to put in here a matrix, but you only gave the program a string, so this is just incorrect, and then it will tell you, okay, you made here an error. This is incorrectly parsed. Please correct this. And this is what I want to show you now with the verification method shortly. 2 methods are available by using pynxtools. First, there is the read NeXus function. Yeah, this is the command read _ NeXus -f, and then the output file which we have created. And then there's another possibility that is called verify NeXus. This is still in development, but I want to let you also try this out because you already have installed pynxtools. The first line, you just should be able to execute it without a problem. So for example, here now I can list the files which I have here in the directory in which I am. You can see here the output NeXus file, read _ NeXus -f, and then output NeXus file. And then the program will give us an output. I would like to see or test if you can also do this, yeah, if you can execute this read NeXus command, and then you have a quite detailed output of all the parameters what you see here in the NeXus file. This is also used in development. So this is why this is called read NeXus, and there's also the other function verify NeXus, which is more like what you like to see. But you can also use this if there are some fields which are missing or which are incorrect. Then it would tell you that this field is not in schema. I will show you later how this looks, but if you can execute it, that's cool. then you can use this. So the second method is the verify NeXus method, which you can also apply to the output NeXus file. You usually can install it with this command here, but in case this is not working, you can also use the development install to use this verify NeXus function. So to do this, I set up here a complete new Python environment called py39_2. You see here no packages are installed. And then you have to use Git to install the Git version of pynxtools. So you just clone the repository. Then you have to go into the pynxtools download, and then you check out the respective the Git the respective branch in which this HDF5 based validation is developed, like this. Yeah. And then you just perform the default installation for development install, which you can also find on the GitHub repository site. It's done like this, takes a little bit of time. So now it installs the package here. These command lines are also shown here. Yeah, we are now at this step here. And let's see, okay, it finished. Now let's do the last step. So what we are doing here is that we make an editable Python environment installation of the pynxtools version. And we also include some specific tools which are required for pynxtools. There was somewhere a typo. Or yeah, this. So and now we should be able to call the help function from verify NeXus. This is the output. You see this function works. Now you can also operate the verified NeXus function onto the output NeXus file. I have to go back to the repository, to the folder where this NeXus file, output NeXus file is. Yeah, that's why this did not work here. And then you can perform this function on this file. This is the file what you see here on the top, yeah, what we also have shown earlier. And now you see here some specific remarks. And this tells you which things you would have to attribute to fix to validate this NeXus file. I come later to a little bit more details on this verify NeXus function, but this is the way how you install it and how you use it. In principle, this command verify NeXus output, I have here some example for you. This should give you such an output. Yeah, you have the command verify NeXus. NeXus, for example, here I use the file NX example file, and for example, then you have such an output that you have your warning, and then it tells you a missing attribute. Yeah, for example, here in the entry, the definition requires that you state which version you are using for the NeXus definition. It also requires you to provide an URL and so on, also an experiment type, and this is what the program then should tell you. What fields are missing, and then you have to address each warning to eliminate, and then it can tell you what things are missing. In case you missed something as you've gone through this manually, or could also be that, for example, in the pynxtools reader, that there is some specific path not missing or found, that the metadata in principle you provided, but the reader is not converting it. And so by this, we can then verify what is missing, what is not missing. And for the read NeXus, the output would look like this. It's extreme long. You can save it to a text file and so, and then search for such messages where not in schema. And then this is an indicator that something here is wrong. It compares that with the NeXus definition language which you have installed, and then you can find what things are incorrect. There are also other tools. I just show you shortly the possible tools. A little bit older one is C and X validate. It's a C-based, programming language C. And this would be somehow the path, so to say here, the path to the NeXus C and X validate executable. Then you have to provide the path to the NeXus definition you want to use. And then there also you have to provide where the output should, which file it should use to check for. And then it gives you an output, which is similar to the NeXus validate, which tells you this is incorrect, this is missing, and so on. There's also the pynx package, it's also Python-based, also quite short command, gives you really cool output, quite nice table. Some things are missing and so on. Which things are missing. Some things are, yeah. And then last thing, as you already see from the name, the NX validate, as far as I remember, this is extension of this CNX validate package, was based in C, but now implemented more Python. And here the command is now called NX inspect. You have to provide the file what you want to check, and also the NeXus definition language file which you want to check for. Yeah, and then with these commands you can check this file, and then it tells you, okay, this is incorrect, this is correct. That's fine. All right. Also for this we have a tutorial. Validating NeXus files, it's called. It talks a little bit about the NIAC and Fermat NeXus definitions, which gives you a little bit more details, how to comment something on the application definitions, and then it presents the basic tools, pynxtools, CNX validate, and pynx. And you have here examples, and then hope that with this, let me copy this to the chat if you want to take a look at it. With this, you can see how the things works and reproduces for yourself. Yeah, and with this, I hope you have also then enough other content to validate your NeXus files. This I also now showed here, so to say, to verify this file, and then in the end you can upload the data to a repository, and then you have really fair data. So I showed you the pynxtools, then the specific plugins for Raman and ellipsometry. I showed you how to use the H5Py package if you want to use the basic Python to create this NeXus files, how NeXus files look, and then also a short part about the verification. And after that, you can upload the data to a repository. And for example, this can also be done in Nomad. This is then now shown by Chris. And with that, I thank you for your attention.